Okay, there we go.
We're going. I haven't said anything yet. Hello, everybody on Zoom. Welcome. Oh,
Hello.
you can't see me. Welcome.
Hello.
I guess we'll get started because it's time to get started. Welcome to Analytical Physics 3. Woo! We're doing this in a very weird way. For those of you who are joining us on Zoom, I'm just going to give you a brief turnaround to show everybody who's out there. You can see where we're at. We're in Newton 204. This is all obviously rather weird. There's a big plastic screen in front of me that I'm gonna kind of stay behind and kind of not stay behind. So obviously this is weird. Thank you for coming. Those of you who are here, thank you for joining us on Zoom. Those of you who are not here, thank you for wearing your mask. Thank you for setting up in a seat that's at least 6 feet away from everyone else. You guys have already aced the first test of the semester. So thank you for that. Lots of my colleagues are worried about students not being compliant. I had zero doubt that you would all do what you had to do to be here. In fact, this whole thing is a complete experiment, right? We have no idea how to teach a big class like this in the middle of a pandemic. It's going to take all of us to stay on campus for all semester. Many of my colleagues are skeptical that that will even happen. It's going to take just doing the right thing for everybody to make this work. So I'm going to try to do my part. I have my mask. I came with a Geneseo issued face shield, which I'm probably not going to wear very often, except in unusual circumstances, in part because it's weird and I don't like it, in part because I think it's probably harder for you to hear me. So am I understandable by people in the back row? Okay, good. Masks will muffle everything that is said. If you can't hear me, if somebody who is listening on Zoom can't hear me or understand a specific thing that I'm saying, raise your hand, let me know. I will do my best to enunciate in a more clear way. Obviously, if anybody throughout the semester has questions in class about what's going on, raise your hand. This will be I want to make this as normal as possible. I want to I value this face-to-face. I think there's a value in doing things synchronously and in person that you don't get just online. This is why we're all here at some level in college and not just taking University of Phoenix classes. There's something you get here that you can't get just online. That said, we're going to make it everything we can. I know some people can't be here to do this synchronous thing as well as we can. If there are questions from people online, unmute yourself, ask me. You probably won't be able to hear questions that are asked in the audience. I will try to remember to repeat them so that you can hear them. If you ask questions, I will repeat them to the in-class people, and we'll try to just make this work in whatever way we can. Okay. I'm not going to have this Zoom up for much of the semester. I can't minimize a Zoom while I'm recording. That's interesting. I did not know that. Okay, good to know. All right, so here we are. I'm not sharing anything with you right now, but let me do that right now. let me go ahead and share my desktop. Okay, hopefully the Zoom people are now seeing my desktop, and I can go ahead and start this. I thought a little bit about how I was going to try to do this whole thing, knowing that there would be people who wouldn't be able to come. And normally when I'm in class, I'm using the very generous amount of whiteboard space that we have here to do lots of lecturing and writing equations and working problems on the board. I knew that was going to be difficult to try to capture for the people who weren't here. So I'm going to go back to, actually I've taught this now, I don't know, this is my 5th time teaching this class. The first time I taught it, I didn't use this and instead used this. This is a whiteboard symposium. It's a smart board. It has the advantages of being able to be streamed up here and through my laptop so everybody can see it, which is why I'm going to use it this semester. It has the disadvantage of having a screen size that's about like this, which is a disadvantage, a big disadvantage. And the main reason why I stopped using it 4 years ago. So the disadvantage is you're not going to be able to see all the work that we've done over the past half hour on the board at one time. I understand that sometimes it's valuable to be able to see that real estate. It's okay a couple of times a class, at least, if somebody raises their hand and say, can you just scroll back to, it will all be here. It will just be scrolled up. I'm happy to go back and scroll up and let you see what was done 20 minutes ago, 10 minutes ago, several times a class. That's fine. We'll just do what we need to do to figure that out. Also, I'm recording all of these lectures. If there's something you missed, you can always go back and watch it. This is one of the advantages of doing all this as Zoom. That was never an option before. You miss class, you miss class. You miss class now, well, you can live sync it. And even if you can't live sync, live view it, you can view it after the fact. So if you miss something, you can go back and get it later on. Yeah. The question was, am I going to post the recordings on YouTube? Yes. My plan, I think, is to, we'll see. There may be some weird cloud stuff that makes it easier to do something not on YouTube, but my plan right now is to upload it to YouTube and then post the YouTube link on Canvas. You were in my Astro class last semester. We did lots of YouTube last semester. Excellent. Any other questions about how this is all going to work? If you aren't feeling well, don't come to class. The way I understand this is going to work is if somebody in this class tests positive and was in class, all of us have to quarantine for 2 weeks. So you're not just doing yourself a favor by staying home, you're doing everybody a favor by staying home when you don't feel well. So I will do the same thing. There may come a point in this semester when I don't feel well. You'll get an email from me. We're doing this class on Zoom today. I'll do it from my office, or we'll just cancel class and we'll figure out something else out. So hopefully we can all have our backs this semester. Great. All right, let's get into the class itself. That's interesting. I don't really want to see this. Let's move this down here. Oh, no, I just did that. Okay. So, you know, there's a way that I don't have to hide some of this. Okay, that's better. All right, I'll just put it up there. So, some information. Quick show of hands. Who was not a Geneseo student last year? Is there anybody who has transferred in? 1, 2, 3. Okay, great. Welcome to Geneseo. We're happy to have you. You're not behind in any way. I'm sure your physics 1 and 2 classes were similar to our physics 1 and 2 classes. The things that you will be needing to catch up on are lab stuff mostly, because we've spent a whole year training everybody else in this room on how exactly we want labs done and how lab reports are done and how logbooks are done. So you will have a lab certainly in this semester. That is physics 226. For the first time in my career that I've been teaching in a fall semester, I'm not teaching a section of Phys 226, which I'm a little disappointed in. I've been here a long time, and it's a great lab. You're gonna have a lot of fun in there, and they have some really interesting ways. I mean, labs are the hardest thing in a pandemic to figure out. And I think they've done a good job of trying to maintain the learning outcomes that will happen with the lab, despite the challenges that will come from being socially distant. So there is that. My office is ISC 217. Most of you know where that is. The second floor of the ISC, which is the physics wing. I'm on the south side, near Dr. Fletcher, and near the Analytical Physics 3 lab. So ISC 215, just almost next door to the lab you'll be in at least half the time this semester. This is actually from last year. Labs do meet, bring laptop, notebook, 3-ring binder. I actually haven't talked to this year's lab coordinators to know if that's the case. I'm assuming that's the case, but you should check in with them, with your optics and modern physics professors to find out exactly what you need. Because I know not all of you will be showing up every week. So I'll let them communicate with you about that. I have office hours twice a week for 2 hours at a time, Wednesday mornings and Thursday mornings. This is has usually been a very cool time. Students will just come in, have an outer office, they'll set up and work, and I will be minimally involved almost at some level. It kind of turns into a study group. That's not ideal way to do things in a pandemic, sadly. I'm not I would love to have in-person office hours. I just can't let it get to a 10 people in the room working on homework problems. So I'm going to start at least virtual only office hours, and we'll see how it goes. My idea at this point is I will open up a Zoom session at 9:30 on Wednesday morning. You can log in and ask me questions. Anybody who's there can ask me questions. My idea is, this isn't the only class I'm teaching 2 other classes, that I've never used a breakout room in Zoom, but I hear they work pretty well. And that I will probably, if you're coming into office hours for help with Analytic 3, we'll have a little breakout room for Analytic 3 where I'll poke my head in every now and then and answer questions, but you guys can virtually gather as sort of a working group there, talk to each other, work on your own, whatever it is, and work through problems. I'm hoping that can be sort of almost as good as being in the same room at the same time working on homework problems. Physics is a social thing. It's something that you shouldn't do necessarily by yourself in your room all the time. You learn a lot more talking through it with somebody else, explaining it to somebody else, getting explained to it by having it explained to you by somebody else. That interaction is very important for getting the concepts down and understanding them. So hope we can not completely lose that this semester. Okay, I do have a syllabus. I'm gonna look at it. Sure, let's look at the syllabus. This is it, that's it. So many of the things I just told you. I have an email address. You can email me. I check it most of the time. So office hours are virtual. Does that mean you can't come in and see me? No. It means I don't want 10 people at a time in my office. But if you have some questions or some concerns, even during office hours, even not during office hours, feel free to stop by. I'm comfortable with 1 or 2 people being in my office with masks on. I don't think that's going to be a huge deal. So feel free to drop by. When this class meets, we made it. We will be using 2 textbooks this semester. This is an important thing. One of those textbooks is the textbook that we used in this class, that you used if you were here last year in Analytical Physics 1 and 2. It is the big introductory physics textbook. If you took Analytical Physics 1 and 2 somewhere else and have a different Physics 1 textbook, do not go out and buy this textbook. Your textbook will suffice. Everything that is in here is almost assuredly in yours as well. The chapter numbers will probably be different, but that's okay. We're going to be talking about interference and diffraction, and I'm going to tell you the chapters for interference and diffraction. And here, you'll need to figure out what chapter that is in your textbook, but it's all the same. If you don't have a physical copy of this book, that's okay. If you don't have an electronic copy of this book, that's okay. Or any other book, that's okay. There are very good introductory textbooks that are completely free and online. Check out openstacks.org. There is an introductory physics book, volume 1 and 2, that has everything that this one has and is completely free and downloadable. So if you have questions about that, you can let me know. Do not go out and buy a textbook for the first third of this, 2/3 of this class. I'm gonna basically go through all of, there's a syllabus, this is on Canvas, you can download it. I'm not gonna, there are slides though that go to sort of go through all this stuff. So you should download it and have this on your laptop, but I'm going to go back to my PowerPoint slideshow because there's some other things on here that I want you to see. So the first 2/3 or so of the semester will be, again, working out of this book. The second book, which you probably don't have and will need, we won't be even getting to until November or so. If you haven't bought it, don't worry about it. The other thing about this book, though, is this is the same book that you will need next semester for Analytical Physics 4. So that is a bit of a savings for you. This is our modern physics book. When we start getting to the end of the semester, we'll be getting into some modern physics topics. And that will be useful then. Special relativity, beginnings of quantum mechanics. Let's go back to the one thing that I did want to show you on the syllabus that isn't on here is the weekly schedule, the things that we're going to be doing in this class, and when we're going to be doing them. This is a slight departure from the last times, from any time at the time I've taught this class. I would always start with fluids and then go after fluids back and talk about light. I thought it was better to talk about light first and then fluids. So we will actually be changing the orders of the homework sets that were done in past semesters and changing the order of the topics that are covered. Same exact homework sets, just in a different order. So just be aware we're starting off with electromagnetic waves. Light is sort of the theme of this course. It's a hodgepodge of topics, but if there were one theme overriding all of it, it would be light. Although it is true that fluids aren't really have anything to do with light, and neither do Archimedes and Bernoulli's principles. But aside from this 2-week sort of interlude in the middle, everything else goes back to light at some level. So that's the major theme of the class. Great. Also, unlike previous semesters, we're going to do 4 exams in this class and not 3. In previous classes, it would be similar to Analytical Physics 1 and 2. We would take 2 mid-semester exams, which were 2-hour affairs in the evening some Thursday, and then a final exam for 3 hours that covered the entire class. In light of pandemic and things like that, I've decided to add an exam, but make them in class and 15 minutes only. So we'll have 3, you can call them midterm, mid-semester exams, on the dates that you see there, 2 Fridays in October, a Friday in November. That's the Friday before Thanksgiving. And then exam 4, the last day of class, Monday, December 21st. That is also, from my understanding, the last week of classes is not exam week this semester. The last week of classes is a normal scheduled week of classes in which we can do whatever sort of final activity we want. I'm planning to, we'll see how far we get. I may miss a class or 2 here and there. 1, because we have an extra exam, and 2, because who knows what will happen with health issues. Let's say, that Monday is the last day of classes. And my plan right now is to have our fourth midterm exam, which will not be cumulative, but will just cover the last topic since the last midterm in that last 15-minute period. So that's the plan right now. You might be wondering at home how that's going to work if you're not here. Good question. I'll let you know in the coming weeks. This is always the hard. Well, it's always going to be the hardest part. How to do assessments in this sort of environment. We'll find out. Okay, cool. There are those. Again, you can take a look. Okay, how are we doing homework in this class? We will be using the Kappa online homework system. Kappa has lots of advantages and a few disadvantages. The major advantages are, one, it's free. It's completely in-house. It costs $0.00 for you to use. It costs $0.00 for me to use, although we do need some CIT support to keep this thing running. It's housed on a computer over in South Hall, I think, and everything, and it's completely customizable. I have lots of power and ability to design homework problems and things that are very tailored to what I want to do. The disadvantages, it's a little quirky, but I think that's a fairly minor disadvantage. So there is a homework set up. You've gotten an email from me about this homework assignment. It should be a review of the material from Analytical Physics 2. I know it's been a long summer. I know that Analytical Physics 2 didn't exactly end in any normal way last semester. So all the more reason why we need sort of a refresher on the topics that we covered at the end of last semester, all of last semester. So take a look at that. Don't wait until Friday to start it. You know, there's Gauss's law problems on there and Ampere's law problems on there and Faraday's law problems on there and things like that. So do get started on that. And it will lead us right into Wednesday and Thursday and Friday's classes where we're talking about electromagnetic radiation and light and things like that. So it's all going to be tied together. It will be due Friday at 5 p.m. This is an unusual time. I want to give you an extra day the first week to get this one done. In the future, what I'll do is post the Kappas on Friday, and they will usually be due on Thursday evenings, sort of at midnight. This particular homework assignment, you have 10 answers, 10 tries per question before it locks you out. There is no penalty for getting an incorrect answer the first time or the second time or the third time. If you get it on the 5th try and it's right, then you get full credit for the problem. But there will come a point where you don't have any tries left, and then you won't get credit for that problem. The first homework assignment, you can play around with things. You've got 10 tries on. That'll go down to 5 tries in future homework assignments. I want to show you how this works because it takes a little getting used to. Kappa is not just a user-friendly thing. So let me show you how this actually works. I'll take you to the Canvas page for this class first. You can see I've uploaded the syllabus. You can download that. There's some syllabus resources related to COVID-13. There's Kappa Set 1. I'll talk about the reflective writing in a second. If you click on Kappa Set 1, you don't have to go through Canvas to access Kappa. All you have to do is type in kappa.geneseo.edu into your web browser and you'll go there. There is an assignment for each of the assignments on Canvas, and those typically will just have a link, maybe some instructions, and a link to the Kappa page. But this is so that when I upload your grades to Canvas, there's a placeholder for that particular set there. But you don't need Canvas to access this at all. You can use Canvas to access it, but you don't need to. So if you click on this link, you'll be taken to this home page, the Geneseo Kappa page. And there's 2 main links at the top, and you will almost always only be using those top 2 links. There are other useful pages, especially when you're new to Kappa, that will be useful. For instance, Kappa is great at handling units. It can handle kilograms per cubic meter per millimeter per hour if you want it to. And it can convert that into anything else. But you need to know how to put those units into Kappa, and it's not always obvious. There are instructions for downloading and printing your homework sets. I'm going to show you how to do that now. If you need help, you can click on it. Instructions for using Kappa, but probably the link down here that's most important is the list of acceptable units for Kappa. How do you put in years? How do you put in hours? How do you put in, well, there's a specific way to do it, and this is it. So these are the base units in Kappa, and you can use standard metric prefixes. So millimeter, you can put in mm. It will understand that first M as a milli and the second as a meter. Micro, for instance, is a U and not the Greek letter mu. And these are everything else that's in there. Ounces, foots, light seconds, liters, newtons, calories. Again, these are all derived units from the base units, and you can see how they're defined here. But if you want to know how to use a Weber or a lux or a sievert or a year, this is the symbol that Kappa recognizes as that particular thing. If you're ever wondering, they're all listed here. Okay, that's enough of that. How do you access this thing? Well, you click on the download your homework set first. You find our class. You look at all these physics classes that are using Kappa this semester. There's lots of 300 level classes that you'll be dealing with next in the coming years where you'll be dealing with Kappa. It's just that good. This will start to get populated as we go through the semester. Right now, only set 1 is up. Click on set 1. There is a homework assignment here for every single person in the class. So find yourself. It is unique to you. I've got one at the bottom here. I will show you mine. And this is a nice formatted PDF file. I recommend downloading this. You can print it off if you want to. You can save it on your hard drive. But this is where it's easiest to read and work on the problems with the PDF version of the set. There's several pieces of important information in the header column here. What set it is, when it is due, obviously the class, and your Kappa ID. This Kappa ID is sneaky, but very important. That Kappa ID is your ticket to getting into and logging into the system as yourself, right? Every person will have a unique 4-digit ID associated with each Kappa set. And when you log into Kappa and you put in that 4-digit ID, it will automatically put you into the Kappa set for that week. So you're going to get a different 4-digit ID for every single set. Part of the reasons for downloading the PDF is so that you can find out what your Kappa ID is. That's going to be important and unique every single time. Okay, once you have downloaded this, printed it out if you want to. My Kappa ID this week is 3427. You can go back to the main Kappa page and click on the Go to Kappa to enter your homework. Three things you have to do here. One, you have to specify what class. P223 will not be the default. Every single time you log in, you're going to have to scroll down to P223, F20, put in your student number. This is your actual G number, G00, whatever it is. And then put in your Kappa ID, that 4-digit number. Again, your Kappa ID has the G00 in it, so don't forget to put that G00 in it. When you do that, you're going to click here to work on Kappa, and it will bring you to this page. To try current set, it knows what set you've logged into, and you can try the current set. You can, it's not going to do anything this time, but when we're on set 4, let's say, and we're about to have the first exam, and you want to go back and find out what you did on Kappa set 1 and 2, let's say you didn't get one right. If you click on View Previous Set and put set 2 in there, it will show you set 2, and it will show you what you answered. And if you got it wrong, it will show you what the right answer was. So this is useful information that usually isn't available, obviously, until after the set has been closed. But it's always possible to go back and look at previous sets and see what the right answer was. by using view previous set. This time though, of course, we just want to try current set. This is what it looks like. And again, all of the text that is on the regular PDF should be here as well. So if you want to read the problems here, you can. They're often presented nicer and easier to read on the formatting's nicer on the PDF. So if you're having trouble reading this, you should go look at the PDF. But everything should be here too. All of the images that you need should be here. And sometimes the formatting isn't that bad either. These are links at the top. If you want to go straight to question 11, you can click on the dashes below question 11, and it will take you down there. These will change as you start answering questions. So let's just try some and see what happens. So for instance, number 1, let A equal 15.4 and B equal 36.7. What is A plus B? This is not designed to be hard. This is not designed to test your math skills. I know you know how to add. This is just a, how do you enter entry? How do you use kappa? How do you enter a number into kappa? How does this actually all work? So let me get this wrong and I'll show you what happens. Let me put in, I don't know, 12.3. Actually, I'm just gonna put in 12 and we'll see what happens. So I put in 12 and I'm gonna submit all answers. By the way, submit all answers really does mean submit all answers. If I have a number here and I accidentally typed a space here, it's going to accept both the space and the number that I wrote. So be careful, it really does mean, now you don't have to answer everything. If you have not put anything in that box, it's not gonna actually submit an answer for that. But if you have put something in a box, any box, it will submit everything that has something in that box. So be careful. That's an easy way to lose tries. No, I think that hitting enter will actually act as hitting the, we'll do exactly the same thing. I think it will just end up hitting that button. I've not done a lot of experimenting with this, but just be aware. There's no real reason to do, there's a few times this semester where I think we'll do, you have to answer multiple at the same time to get it right, but almost every time you should just be doing one at a time. There's no real reason to be doing multiple at the same time. You can submit an answer on Monday and come back on Tuesday and submit another answer and come back on Thursday and submit 4 more answers. There's no limit, or you can come back and work on this later on. Don't wait until you think you've got all the answers and then put them all in at once. That's just silly. Okay, let's try 12 and see what happens. Aha. So it's given me, you see what happens? I've got an S up here now under 1, capital S, and it's giving me a warning here. And the warning says, please adjust significant figures. You've provided 2 significant figures. Try 0 out of 10. So this is one of the weird things about kappa and the way these problems in particular are coded. Almost every single problem this semester has been coded to require at least 3 significant figures. Even if the answer is 5 and it's an integer, if you put 5 in, you're gonna get this error message. And it's gonna want you to put in 5.00. It's gonna need at least 3 sig figs in every answer that you put in the semester. That's weird. Even if it's an integer. It's okay. It's a quirky thing, but that's fine. You'll notice though that we've still used 0 out of 10 tries. It has not docked me a try for doing this, right? I still have 10 tries left. It hasn't evaluated whether that answer is right or wrong. It hasn't told me whether that answer is right or wrong. It's just said, hey, that's the wrong number of significant figures. Try a different number and I'll tell you if it's right or wrong. So I could put in 12.0 now. Oops, 12.0 and submit all answers. And now it says, aha, good job. You did the right number of significant figures, but bad job, that's the wrong answer. And so now you'll see there's an N there. I've gotten that one wrong. And it'll show me what my last answer was. And now I have used up one of my 10 tries. Okay. One of the other things that's nice about those websites where you do paid for homework is you can look at all your answers that you've ever submitted. That is not the case with kappa. It will show you, if you just submitted it, what the last answer is. But if you close this web browser back and come back to this, it's not going to show you what your last answer was. One of my big advices for using Kappa is keep careful track of every answer you put in to Kappa. You don't want to lose points because you tried the same answer 3 times, even though it wasn't right any of the times, right? So keep careful, be organized as you're doing your homework. Write out the answers. Say, try 1, use this answer, right or wrong, yes or no. If it was wrong, you've got a record there and you know not to try that answer again. There's a tolerance. Obviously, you don't have to get the answer exactly right. The tolerance is usually about 1%. So 3 sig figs should be plenty, which is why it's usually set to 3 sig figs. But you don't have to carry it out to the 8th digit. You don't want to. By the way, I think there's an upper limit on the number of sig figs. This is kind of fun. If I do 12.015, it's going to say also, unit. Oh, I read that as a unit. So that's another problem. But let's just try this. 12 point. I must have put a comma instead of a 1. So decimal point. Submit all answers. Also sig figs. So I provided 20 significant figures. It didn't like that. I think the number is between 3 and 12. If it's above 12, it won't accept it either. There's no reason to ever put in 12 sig figs. Nobody ever runs into that one. It's always the smaller one that people run into. Okay, well, let's actually do this. 15.4 plus 36.7 is 52.1. Is that right? Hey, that's right. So 2 things happen now. The status of this goes to yes, which means I got it right. And it says yes, computer gets 52.1. This is can be important because sometimes you will have gotten close but didn't get it exactly right. And if you're within 1%, it's going to give you credit for it. But the number that's there might not be the exact number that you put in. The number that's there is the number that the computer thinks is the exact answer to this problem. And if you need that answer to go to the next problem, for instance, it's better to use that one than it is the one that you put in. So just be aware, that is the number that the computer thinks is exactly right. Okay, A minus B, I'm not gonna bother to do these. You can sort of get the handle on it now. Okay, units, how do units work? Let's do one with units. Here's an answer. An electric field has the components of EX, EY, and EZ. A unit cube has corners basically at the origin and extending to +1, +1, +1 in all directions. Calculate the electric flux through the cube at the side X and at the side Y. So it just wants a number here. Let's try a number like 10. Again, you can probably guess what's going to happen. I'm going to get, actually the problem now is not that I haven't submitted enough significant figures, but that it was expecting a unit and I didn't get one. That's what the lowercase u means. It was expecting a unit and it didn't get one. Again, it has not evaluated the number because it can't, because it doesn't know what the units is, and it hasn't docked to a try, but it hasn't evaluated the number yet either. If I do 10 and give it the wrong unit, like newtons, it's going to give me a capital U. It says, okay, I see that you put in a unit, but that's not the unit that I was expecting. And it's not equivalent to the units I was expecting. One of the nice things about Kappa is if I have an answer that needs a distance, let's say for an answer, I can use meters, I can use kilometers, I can use millimeters, I can use inches, I can use fathoms. It doesn't matter. It will do the conversion for you and check it against its number and see if it's right. So the fact that I've gotten the unit wrong doesn't mean that I'm using the wrong value of distance unit. It means that I put in a distance unit and it wasn't expecting a distance unit. Kappa's smart enough to be able to answer that. Ooh, I'm out of practice in lecturing today. The voice is already gone. All right, so obviously this should be newtons per coulomb. Let's do 10 newtons per coulomb, submit the answer. Now I'm gonna get, oh, it didn't work. Because it's flux, right? This isn't just, that's field. Flux is, I need another probably per square meter, times square meter. I think you're right. Newtons times meters squared per Coulomb. That didn't work either. Uh-oh. Electric flux through the cube. Say again? Oh, it didn't. Okay, great. Now I got the unit right, but I don't have enough significant figures. So I need a 10.0. You get the idea. 10.0 newtons times meters squared per Coulomb. Okay, and that's just wrong. Okay, but at least we got to the point where we know what's wrong. But this is the kind of thing that sometimes you'll have to do this several times even to get Kappa to tell you whether it's right or wrong. But now we've got, what's wrong, and now we finally used up one of our tensions. Okay, any questions about Kappa or almost, yeah, question. Yes, good question. Any number can be expressed with scientific notation. If I wanted to do 10 in scientific notation, let's just try it here. The preferred way is with an E. 10 E negative 10.0 E negative 3 is the way to put 10 times 10 to the negative 3. 10, that was a bad example because E means times 10 to the, if I want to do 3 times 10 to the negative 3, it would be 3 E negative 3. I didn't actually write 3 there. 3 E negative 3. But I really need 3.00 E negative 3. If you get the drift. But that's right. The capital E is the best way. And I'm not sure the spacing matters. I think it does. I think if you don't put a space, it interprets that E as an exponent times 10 to the, if you do put an E, a space, it will try to interpret that as a unit. Does that make sense? Okay, great. Any other questions? Any other Kappa questions? Almost every question that we ask you this semester will be put in a number in the blank for the units, but some of them will be put an equation in. Some of them will be trying to think if there's any actual multiple choice. There may or may not be, or matching, or there's ways to do all of that stuff within Kappa, but it will almost always be something like this. Okay, great. So take some getting used to. Don't wait until Friday to start this. The exams? Yeah, good question. Exams right now I envision written in class. I haven't figured out at all how to handle that with people who aren't here yet, but I have a few weeks to think about that yet. But as of now, yeah, you'll get 2 or 3 problems, work through it through 50 minutes, hand them in at the end, go about your way. Okay, great. Other questions? Okay. Oh, there was one. Did you have a question? No. I'm seeing things. Never mind. Okay, so Top Hat. How many have never used Top Hat before? Okay, not many of you. Good to know. We will. I like Top Hat. We have a subscription for it in the department, in the campus. It's free for all of us to use. I will, not every class, but many classes, be throwing out Top Hat questions for you to answer. Did I even download it? I did not. That's sad. We'll try this next time. This is a brand new laptop. Oh, stop. That's not what I wanted to do. This is a brand new laptop. I think I actually have to, I got it. I'll just do this way. Normally I'll be running the app and I'll just throw it up. But right now, let me just go to tophat.com and I'll show you how this works. Log in. Hey, here we are. Did I send you an invitation to join this class yet? I should have done that too. I'm rather irresponsible. So here's what I'm going to do. I will do that later today. For now, here is the join code. In fact, actually, I will be doing this every single time. I have been asked to take by the administration to take attendance every single day to know who physically is in class every day. So what I will do on days moving forward is somehow have an attendance thing up at the beginning of the class. There'll be some way, yes, I'm here, click the button on Top Hat. I don't care. It's not anything that's gonna go into my grade book, but if somebody tests positive in the room, they need to know who else was in the room for contact tracing, just to clear all that stuff out. So even if you're here visiting remotely, looking at you Zoom people, don't click the attendance thing that I'm here, because the sole purpose of that thing is to know who was in the room every given day. Okay. So let me just do that real quick, see how that works. If you've never used Top Hat before, there's 3 ways you can do it. You can log on to the webpage, tophat.com. You can send an actual SMS text to that number. And the easy way is to download the Top Hat app, log into the class, and all the questions will come up and you can put the numbers or the things in as you go. So that's our join code, 648299. That's a unique code for this class. I will send out an invitation to join the class later on if you want to also. But for now, don't worry too much about this today. We'll start really taking attendance and doing this thing. Oh, this is all for practice today anyway. There's no point associated with any of this today. We'll start it for real on Wednesday. This is a small portion of your grade, 4%. But you know, what if you can't come to class? What if you're sick and quarantined and doing some other things? In the past, I would leave it open for a minute and then it would close and it would be done. This semester, for COVID reasons, I'm going to leave every question up for 24 hours. So if you want to come back and answer a question later on, go ahead, feel free to do that. I'm just going to leave this up for a second. If you haven't submitted it, that's okay. In fact, I'm going to finish this now. If you haven't finished filling it out or gotten there, that's okay. It's not a big deal. I'm running, what have I got? 3 more minutes? If you have questions, you can contact Top Hat support. They're reasonably good at getting back to you. I haven't had a lot of problems. I think this works fairly smoothly. This is 4% of your overall grade. 1 point you get 2 points for every question, 1 point for answering it, 1 point for getting it right. And it's open note and open neighbor. In other words, these aren't quizzes. This is difficult to collaborate, but the point of these is to sort of have a conversation with your neighbor about what's going on, which is difficult, I realize, in the situation we've got here, and if you're on Zoom, but well, whatever. Anyway, you don't have to get a perfect score throughout the whole semester to get a perfect participation score. If you get above 80% for, again, 1 point for getting it right, 1 point for answering it, for the whole semester, that's 100% all 4 participation points. So if you miss a class, don't worry about it. It should not affect your grade at all, as long as you're here most of the time. Should we go ahead and ask these? I was going to ask these, but we're down to 2 minutes left in class. Let me come back. If we've got time, I'll do them at the end. Canvas.geneseo, I showed you already. You can download the syllabus. I'll be posting lecture slides there, the slides that I'm showing in class. This slideshow's already on there. Announcements, this is important. I probably won't be sending emails much. I'll be making announcements. So you should set it so that your settings sends you an email every time I put an announcement up, or you might miss some things. Announcements are nice because they just stay on the top of the Canvas page and you can see them there anytime. So if there's important stuff and I send you an email, it will always show up there. You don't have to scroll back through weeks of emails to find things that I've done. But make sure your settings are such that you're getting an email every time I make an announcement, or else you might miss some of those things that come up. Zoom links, class videos, it'll all be posted on Canvas. Okay, this is important. You've all made it to Analytical Physics 3. As you know, you've probably lost a lot of classmates along the way. Analytical Physics 1 and 2 does weed some people out, but you're here now. You've made it. You're wanted and you belong. So you should get involved. We have a colloquium series that runs every Thursday. Obviously, it will be weird this semester. Usually we're in this room and there's snacks and there's a cool talk speaker every week, and it's a good chance to get to know physics majors and become a part of the, that's still gonna be happening, but it's gonna happen virtually. You should still come. You'll get an email from Dr. Freeman, I'm sure, this week about that. We have a physics club. Again, I don't know what's gonna happen with it this semester. We have an astronomy club. Anything you're interested in, the more involved you are, the more you put into this department and the more you'll get out of it. So, yeah. The last thing is a reflective writing assignment, and I really am out of time now. This is unusual. I started this last semester and I like it a lot. It has nothing to do, sometimes I'll do with physics, sometimes it won't, but I think it's important to talk about things that aren't just physics all the time. And it's important to reflect on where you've come from and where you're going and how you're doing it. So there is one up now. It's a two-part question. Why are you a physics major? And tell me something interesting about yourself. These should not take you more than 10 or 15 minutes to fill out. If you want to take more time on it, you can, but don't ever feel like you're obliged to. And this is mostly a participation thing. If you fill it out in a thoughtful way, you'll get full credit for it almost every time. So do take it seriously. I read them all. I think it's a good way to get to know you. I think it's a way for you to get to know me. And we can talk more about that on Wednesday if you want to. Okay, and I already talked about the pandemic, so all right, I'm out of time. We'll actually get started with the content on Wednesday. Enjoy your lab classes this week, and we'll meet back here on Wednesday.